Hello, in this video we'll be looking at the last of the graphic design fundamentals, which is color. We've talked about layout and composition, we've talked about typography, we've talked about a lot of things. So there is the last, which is color. The art and science of color. That is, we're looking at the introduction to color, the color components, which are hue, saturation, and tone. The next is color harmonies. We have 7 under that. We have monochromatic, shades, complementary, analogous, triadic, tetradic, and pentagram. We also have color temperature. And lastly, we have color models, which are RGB and CMYK. Color is one of the keys to a good graphic design. It is pertinent as a graphic designer to have in-depth knowledge of color harmony, color components, color temperature, color models, and the language of colors. Now before we move on, we need to look at what we call color wheel. It is called color wheel or pigment wheel. It is very useful for understanding the relationship and mixes of pigment-based paints and ink. There are 2 types of color wheel. The RYB, that is red, yellow, and blue, which is typically used by artists as it helps combining paints colors. Then there is the RGB, red, green, and blue color wheel, which is designed for online use, as it refers to mixing light, like on a computer or TV screen. Now, color component, we have hue, saturation, and tone. So what is hue? Hue is basically any color on the color wheel. Yes, a wheel is omitted there. When you are using a color wheel or a color picker, you can adjust the saturation and luminance of a hue. This color, this is what we call hue, and hue is more like the original color. So that is hue. You can see the colors you have on the color wheel is hue. Now saturation. Saturation is the intensity or purity of the color. And like I said earlier, that hue is just the pure color, the original color. While saturation is the intensity or purity of the color. So the degree of the purity of the hue is what we call saturation. And you can see this picture on the left. That is 0% saturated color. And we have the other one which is 80% saturated. So that is hue and saturation. The next now is the tone, or you call it value, or rather luminosity. It is the amount of brightness or light in a color. Okay, you can see the first example we have here. It's 100% tone. That is, you can see that is extremely bright. Then unlike the other one, 0% tone, you can see it's very dark. We have hue, we have saturation, and we have tone. Alright, so this is another example here. You can see the hue. In these examples, we have red as the base color. You can see red in all the colors. So you can see the original red there, the hue. You can see saturation. You can see the different saturated red there. Then we have the luminance. That is the tone. Alright, so let's move on. Now, next I want to talk about color harmonies. Color harmony is all about using different colors to create harmonious combination in a design. That's when you combine colors together to create a good harmony that is to create a good result, a harmonious result. That's what color harmony is all about. Now, while working on color harmonies, we need to understand the primary, secondary, and tertiary colors. Primary colors in the RGB color wheel are the colors that, when added together, create pure white light. So we are still going to dig in deep into that RGB. But for now, we're going to move on. And these colors are red, green, and blue. In the RYB color wheel, primary colors are colors that can't be mixed from other colors. Yes, of course, primary colors are natural colors that, when added together, give other colors. But they cannot be gotten by adding other colors together. So that is primary color. The second colors are colors that result from mixing two primary colors, while tertiary colors are colors made by combining a secondary color with a primary color. Well, primary color are the natural colors, then secondary, when two primary colors are mixed together, then secondary colors, when secondary color when two primary colors are added, while tertiary colors are when one secondary color and one primary color are mixed together. So it gives us tertiary color. Now look at this. In our color we have primary, we have secondary, and we have tertiary. And you can see here we have the red, yellow, and blue as the primary colors. Then secondary, you can see here we have just like somewhere around there, we have the blue and the yellow intersect here. So when you mix the two, you are going to get this. Then also we have this here, that is yellow and red added together, give us this particular one here. Then also when we have the red and blue together, when they are mixed together, they give us this. So yellow and blue intersect here, then yellow and red intersect here, then white, red, and blue intersect here. And then we have the tertiary, that's when two secondary and one primary is added together. Of course, you can see over here is the secondary, then when yellow is added to it, it makes it tertiary, then this gives us this. Likewise, this, of course, here is the secondary here. The when primary, which is where is mixed with it, then it's going to give us this as well. Then same thing there. So we have the primary, secondary, and the tertiary colors. Now let's move on to the first of the color harmonies, which is monochromatic. Monochromatic shows the three shapes, tones, and tints of one base color. It provides a subtle and conservative color combination. This is a versatile color combination that is easy to apply to design projects for a harmonious look. And as when you use these colors together, it's going to give you a harmonious result. In the first example, we have red as the base color, while in the other example, we have orange as the base color. So you can use all these colors in your projects. Just have to use it carefully, that's going to give you a good result. So that is monochromatic. It's just one single color that you use in different tones. Now shades. Shades are created by adding black to a base color. That is by darkening the color. This creates a deeper, richer color. Shades can be quite dramatic and can be overpowering. Now, just more like the monochromatic, this is just, we also use red as base color here, but we add the black to it in different proportions. And you can see the sequence of the darkness of the red. So from the red and the dark one, the darker one, then we have the darkest there. So you add the black to it. So when you use these colors harmonious together, in the graphics, you are going to have a good look. And that's shades. Now let's move on to the third, which is complementary. The colors that are on opposite sides of the color wheel. This combination provides a high contrast and high impact color combination. Together, these colors will appear brighter and more prominent. And this, unlike shades are monochromatic, they create a strong contrast. And they are colors on opposite sides of the color wheel. Look at the first example here. We have the red and the green there. And you can see the strong contrast between red and green. Of course, you hardly notice any similarities between the two colors. So use this to create a very strong contrast, a high contrast in your design. Also in the other example too, you can see the contrast there. The two colors are not close, so they are far apart, so you use them to create a strong contrast. So you can also use these colors together in your design. You're going to have a harmonious look. And next we have analogous. Three colors that are side by side on the color wheel. This color combination is versatile, but can be overwhelming. To balance analogous color scheme, choose one dominant color and use the other as accent. So it's very simple. Just using color as dominant, or you just add the touches of others. So that's how you make the best out of analogous. Just like the two examples given here. And you can see the color in analogous are quite close. So that's analogous. Let's move on. Now we have triadic. Three colors that are evenly spaced on the color wheel. And as we're going to divide that by 360 by 3, that is 120. They are just 120 apart. 120 degrees apart. So this also provides a high contrast color scheme, but less so than the complementary color combination, making it more versatile. This combination creates bold, vibrant color palette. It also creates contrast, but less like the complementary color, because this is 3, and you can see they are closer, unlike the complementary. Complementary is just like 180 degrees apart, while this is 120. So this made them closer than complementary, and that's what gives complementary higher contrast than this. Let's move on to the next, which is tetradic. 4 colors that are evenly spaced on the color wheel. Tetradic color schemes are bold and work best if you let one color be dominant and use others as accents. The more colors you have in your palette, the more difficult it is to balance. So these are just 90 degrees apart. So it is tetrad. So you can also use these two harmoniously to have a good look in your design project. Alright, then the last on the color harmonies is pentagram. It's 5 colors that are evenly spaced on the color wheel. Pentagram often creates a complex look, but can be simplified by moderately using the colors. So when you evenly use these colors in your design, it's most of the time creates a very complex look, but you have to moderate the colors when you are using them, and that's going to give you a good harmonious look. Alright, let's move on to color temperature, which is the next. Color temperature refers to the warmth and coolness of a color. The color wheel can be divided into warm and cool colors. According to color psychology, different color temperatures evoke different feelings. For example, warm colors are used to bring to mind coziness and energy, while cool colors are associated with serenity and isolation. Warm colors are the colors from red through to yellow. These colors are said to bring to mind warmth, like the sun, because you can see the sun brings warmness to the mind. The cool colors are the colors from hue to green and purple. These colors are said to bring to mind coolness like water. You can see the example there. The color is divided into two. Then we have this first part, which is cool, then the other part is warm. So use this to evoke different feelings. So that's why I said earlier on that color is one of the keys to good graphic design. You want to be aesthetically intact in your design. So you need all these color schemes. Color temperature is one of them. So we want the viewers to feel the coolness or the warmth of your graphics. Then you know the color combinations you are going to use. So let's move on to color model. And the first we are taking is RGB. RGB is red, green, and blue. RGB is the color model for screen. Yes, you should take note of that because it has to do with light. So it's the ideal color model for screen. Imagine a scenario where there is total darkness and a red torchlight is shown on a surface. So that is RGB color mode for you. And the green shown on the same surface. Now partly overlapping on the red. And another blue light shines on the same surface, partly overlapping on red, green, and red and green. The intersection of red, green, and blue with full intensity, that is 255, and that's the maximum degree for RGB color mode, 255. It forms a white color, while the combination of the three at zero level, that is zero intensity, forms a very thick black, which interprets an absolute darkness. So RGB by its nature is positive, so it's adding a positive energy to a negative energy. So that is RGB. Just like the illustration given there in this explanation, just imagine a total darkness, then where a red torchlight is shown on a surface. So that's how RGB looks. RGB is such a color model that adds positive energy, that is light, to a negative energy. The value of RGB with full intensity is measured at 255. As designers, we work more with RGB model, which may later be exported or converted to CMYK model if the design is to be printed. Yes, if you are working on screen, then probably you are designing for an online delivery, then the ideal color mode is RGB. When you want to work for print, you use CMYK. But the reality is, if you are working for a print, of course you are designing your work on a screen at first. So most of the time, you just need to start with RGB, then you can later convert or export it to CMYK. Then next is CMYK, cyan, magenta, yellow, and black. CMYK is the color model for print. Just like I said earlier on, CMYK color subtracts energy from light reflection. So unlike RGB, that adds positive energy to darkness, that's to negative energy, cyan rather subtracts energy from light reflection. When cyan is added to a white paper and magenta to the same paper, the intersect makes a blue color. And when yellow is added to the same area, the part intersecting cyan makes a green color. The part intersecting with magenta makes a red color. The part intersecting cyan and magenta makes a weak black. I mean a weak black because it's unlike RGB. when the whole color is subtracted from the darkness, it's total darkness. So when black is added to each of the color, it becomes thickened, as it becomes darkened. So the value of CMYK with full intensity is measured at 100%. RGB is measured at 255, and while CMYK is measured at 100%. And again, you should remember that RGB is for string, and while CMYK is for print. The intersection of cyan, magenta, and yellow with full intensity, as 100%, forms a very thick black, meaning absolute darkness. Because the four different light reflections, cyan, magenta, yellow, have been subtracted from the light. So that should be 3, because the 3 different light reflections, CMY, have been subtracted from the light, while the combination of the 3 at 0 level, 0 intensity, forms a white color. That's in the absence of CMYK in the light. It's not going to have a power to alter the light. So the light is going to be at full intensity, at pure white. But when you add any of cyan, magenta, or yellow to the light, it's going to subtract from the energy. So that's going to reduce the lightning there. Alright.